So today, boys and girls, we are going to be learning about shapes. And I have a whole bunch of shapes right here. Shapes are all around us. What are some of the shapes you notice? Jace. What are some of the shapes you notice? Jace? Oh, Jason.
Circles.
You notice some circles? What else do you notice?
Squares.
Squares.
Rhombus.
Rhombuses. Oh, I love that word, rhombus. So, what do you notice about these shapes? Actually, what I want you to do is I want you to turn to your partner and talk to them and look at all the different shapes we've got out here. And you tell me, what do you notice about, what do they have in common? What are some differences they have? Let's start. And you have at least one thing you notice, right? Okay, then that's good. So, what do you notice about something that these have in common, and what are some of the things that these have that are different about these things? Caleb.
I noticed that some have points at the top.
Some have points at the top, like the cone?
Yeah.
Okay. Do others have points in the top, or is it just that one?
More. Yeah.
Can you show me? Oh, so you're talking about this point on the top. So if you were to hold it up.
Yeah.
Okay. But what's different between this shape and this shape? Thea?
One's tall, one's wider, and one's narrower.
So is this the wider one that you're talking about?
No.
Oh, this is wider than that.
Yes.
Okay. But what's different about this shape than this shape? Besides, one is wider.
It has 4 corners.
This has 4 corners.
That has. One is flat and one is not flat.
One is flat and one is not flat. So there's a special term for shapes that are flat, and that term is two-dimensional. Have you ever heard that term before? Can you repeat after me, two-dimensional?
Two-dimensional.
Two-dimensional. If this is two-dimensional, this is three-dimensional. Three-dimensional. It's not flat. It goes out into space. All right? Well, not space outside. The space around it, okay? So around everything is space. You're three-dimensional. Are you flat? No, you're not flat. But these sheets of paper are flat, so they only exist in 2 dimensions. If they were tall, if they had width, they would be 3-dimensional. So all these shapes, when you write them on a piece of paper, they're 2-dimensional because we're not getting it, it's not sticking out like that, right? It's not becoming 3-dimensional. So if you were to sort some of these things, these shapes, how would you sort them? What are some different ways you could sort them? Turn to your partner. What do you think? How could we sort these?
3-dimensional and 2-dimensional, because now you know these are 3-dimensional.
Okay.
And you know these are 2-dimensional.
Okay, so we could sort by 2 dimensions and 3 dimensions, 3-dimensionals. Yes, Thea?
You could sort them out with 3-dimensionals and 2-dimensionals together.
But if we sort them together, are we sorting them just as a group of shapes?
Yeah.
Okay. So we know we have a group of shapes. How are we going to divide the shapes up into different categories? That's what I mean. When you sort something, you're dividing something up into different categories, right? So if you sort your dinner foods from your dessert foods, unless you have dessert for dinner, you would put all the chocolate cream pies and the ice cream in one category, and you would put your hamburger and your chicken in another category, right? So we're sorting we know these are all shapes. Now we need to decide how we're going to sort them. Maggie said 3-dimensional shapes and 2-dimensional shapes. True, do you have any other ideas?
Yes. You can like sort
the circles go with the circles and the...
Oh, we can sort the circles and the circles.
Yeah.
What else are we going to sort?
We can sort the rectangles.
The rectangles, okay. So we have some rectangles. We can sort those out.
Yeah.
What other shapes do we have?
We can sort some squares.
Squares. Are you okay? Okay.
You can sort them from small and big.
We could sort them from small. Some of these shapes are small and some of them are big. Yeah.
You can put the yellow ones on the yellow.
We could sort them maybe by color. Does anybody know what the study of shapes is called? What we usually call it? We call it geometry. That's another big word. Can you say geometry?
Geometry.
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 Geometry. And so geometry is the study of shapes and what makes the shape. So it's the study of lines, of angles, and vertexes, which are also the fancy way of saying the points on the shape, and the study of shapes. So we're going to try to sort these and figure out what actually makes a square. Because some of you said, oh, we can sort all the rectangles together. We can sort the circles together.
I don't know. Shown by like the corners and like the...
We could sort them by how many corners or vertexes they have. We could do that.
How many points?
How many points? The point is also called the vertex. That's a fancy word you're learning. Vertex.
Vertex.
You know how to say more than one vertex? Vertices. Vertices. It's like I'm teaching you a lot of tongue twisters today. We're learning about geometry and vertices.
You just said for vertices.
Vertices. So, let's see if we can figure out. Some people said rectangles, right? What? We're going to be learning today about attributes. Attributes are what defines something. Okay, so we want to know what defines a rectangle, what defines a circle, what defines a square, and we're going to be using defining attributes and non-defining attributes. Now, what's an attribute? An attribute is something that makes you, or in this case, a rectangle. So you can be defined, one of your defining attributes is that you're students, right? That's an attribute. It's a quality or characteristic you have. You are students. You also are friendly. So you are friendly students, right? So that's also an attribute, okay? Is one of your defining attributes the fact that you're purple?
No.
No, that doesn't have anything to do with you, right? So we want to think about what makes a square, and a rectangle, and a triangle. So we've got a chart here of different shapes. Now, are these two-dimensional shapes or three-dimensional shapes?
Two.
How do you know they're two-dimensional shapes?
They don't go in space.
They don't extend into space, right? They're flat. Yes, Thea, do you have something to add to that? You wanted to say they were flat, too. So, let's take a look at some of these. Let's group these. We've got some rectangles. Does anybody know what this is called? Thea?
A trapezoid.
A trapezoid. So we've got some trapezoids here.
What about a hexagon? Do we have?
We do not have any hexagons, but we will be learning, I'm sure, about polygons, different polygons. Polygons are shapes with many different sizes, like hexagons and octagons, like a stop sign. Lots of different shapes. They have the same number of angles and the same number of lines or edges. Okay, so what's this?
A rhombus.
A rhombus. So we have some rhombuses, and we have some...
Rectangles.
Are these rectangles or squares?
Squares.
Squares. Actually, let's check. Let's check. You know what? I think he's right. They are rectangles because the sides are not equal. They are not equal. Is this a square or a rectangle?
Square.
It's a square. Guess what? Squares are also rectangles. They're also rhombuses. Squares are really funny things because they fit into a lot of different categories. Because they can be rectangles. Squares are considered rectangles, and they're also considered rhombuses. Right? Okay, and we have triangles. Okay, so what we're going to do is we're going to look at these things and try to see what are defining attributes. What attributes are important to make something a triangle, and what are non-defining attributes? What doesn't matter? Okay, so let's start with the triangles. What do you observe about triangles? What makes a triangle? True.
A triangle has points on the end.
Okay, so it has vertexes. How many vertexes does it have?
3.
It has 3 vertexes. Okay, let's write that down. Does everyone agree?
Yeah. Yeah.
Does anyone disagree? Does anyone have any ideas of why that might not be the case? No, everyone agrees there are 3 vertexes?
That's what I was going to say.
Okay, so we have 3 vertexes. Okay, so 3, or vertexes or vertices. Vertices.
Why are vertexes like
Vertices. Vertexes is wrong. You should not say vertexes. You should say vertices. But it's hard because you guys are learning the terms vertex and vertices, okay? And it's one of those funny plural words, which the plural sounds a little bit different than the original. Okay, so we've got 3 vertices. What else? What else makes a triangle? What else makes a triangle? Addie?
3 sides.
3 sides. Have you ever seen a triangle without 3 sides?
No.
No, it has 3 sides. What are things that aren't important to this triangle? Is this a triangle?
No.
This isn't a triangle?
Yes. Is it triangle?
It's a cone?
No. Yes.
Why do you, no, I'm just curious. Why do you think it's a cone?
I think it's both.
This is a cone.
Yeah. This is kind of like a cone, but sides.
That has sides too.
Yeah, but it has a side.
We're going to be talking a lot about the 3-dimensional shapes soon. But this is a 2-dimensional shape. Cones are 3-dimensional shapes.
Oh, yeah.
Triangles are 2-dimensional shapes.
Right.
So is this a triangle?
Yes. Yes.
Is this a triangle?
Yes.
Is this a triangle?
Yes. No. Yes.
Why isn't that a triangle? Is it a triangle if I do it like this?
Yes. Yes. Still a
What if I do it like this?
Yes.
This?
Yes.
This?
Yes.
Okay, so the orientation or how I have it, what direction I'm pointing it in,
It's still a triangle.
it's still a triangle. So does the orientation or the direction matter?
No.
No. Okay, so a non-defining attribute, something that doesn't matter, is the orientation. Now, are all these are all 3 triangles. So, what's different about them?
They're all different sizes.
They're all different sizes. Does the fact that this is bigger than this matter?
No.
So does size matter? Is that a defining characteristic? Okay, so another non-defining attribute is size. Okay,
Size.
what about color?
No. No. No.
Does color matter?
No. No.
If this was purple with polka dots, would it matter?
No.
No. So size, color doesn't matter. So we have 3 vertices, 3 sides. Do the sides have to be equal?
No.
Do the sides have to be equal? You sure?
Yeah. Those are equal.
These aren't equal, but they're still triangles. Okay, so 3 sides but they don't have to be equal. So I'm going to put that under defining, but not equal always. Right? Because sometimes they're not going to be equal. Okay. What about a square? What about a square? How do you define a square? What are some defining attributes? Jordan, what's a defining attribute about a square? Look at it. What do you notice about the square?
It has 4 sides.
It has 4 sides. Do all squares have 4 sides?
Yes. Yes.
Yes. So it has 4 sides. It has 4 sides. What do we know about a square's sides? Look at the square. Is each side the same? Are they equal? Are they not equal?
Each side is the same.
Each side is the same or
Equal.
equal. So this side is equal to this side, which is equal to this side, which is equal to this side. Those are just tick marks that show you that this is the same size as this, same size as this, same length as this. This is the same length as this. So, squares 4 sides and 4 sides that are equal. You have one?
That they have 4 corners.
They have 4 vertices, right? 4 corners. 4 corners or vertices. Now I'm going to teach you yet another fancy word. You ready? Parallelogram. Parallelogram. Do you know what, and parallel, do you know what parallel means?
No.
Okay, so parallel is when you have 2 lines. Jordan, can you look up here? When you have 2 lines that are right next to each other, but they are parallel, meaning they'll never intersect. So if I were to draw these 2 lines into infinity, they would never intersect with each other. Okay? So these lines are parallel to each other, and these lines are parallel to each other. Okay? So you've got 2 sets of parallel sides. Okay? So we've got 2 sets of parallel sides. And parallel is a concept we're going to be learning more about. Okay? Because it's not an easy concept. What do you mean 2 lines going into infinity? Okay. So 2 sets of parallel lines. Okay. Does color matter?
No.
Does size matter?
No.
Does orientation matter? If I turn it on the side, does it matter?
No.
No, it makes it easier to see as a rhombus,
Yeah.
but it's like 2 equal shaped,
Yeah.
2 the same on each
It's like
side.
bat wings.
It looks a little like bat wings. So it has a line of symmetry. So it has a line of symmetry. So it has 1 line of symmetry. Look how many different words you learned today. You learned parallel, symmetry, vertices.
Write them up on the board.
I think what we'll do is I will come up with some word wall cards so we can see them. All right, so how many sides does a trapezoid have?
Trapezoid?
A trapezoid. How many sides does a trapezoid have? True.
4.
4 sides. Are they equal?
No. Not all the time. Not all the time.
Are they equal?
Not all. of the sides are equal.
Are there any sides that are equal?
Yes. The ones that are across from each other are equal.
They're parallel. You mean these two or these two?
Actually no. They're not all equal because the line on the top is shorter than the line on the bottom. Well, kind of. It doesn't matter which way it was. It could be line on the top.
Okay, so there's one set of unequal lines. Okay. One set of unequal lines. Are there any parallel lines?
Yes. No. No. Yes.
Turn to your partner. Turn to your partner. Talk to your partner. See. Tanner, your partner is Case. Turn to your partner. See if you can figure out if there's any parallel lines in a trapezoid. And this might be because you can't really, my drawing is not as perfect as it could be. So you can look up here for the trapezoid if you need a reference. Are there any parallel lines in the trapezoid? When you're ready, turn to me so I know you're ready to share. Jace.
Yes.
Why? Which are the parallel lines?
This one and this one.
Okay. Those, if I were to draw a line here,
Those are not parallel.
let's look. If we were to draw the line here, and actually I'm going to do it up here because we want to keep our chart.
It would be like a triangle.
Let's see. If we were to draw these two lines, let's trace. If we were to draw these two lines up, would they intersect?
Yes.